Okay, back to mathematical induction. So previously we went through the fundamental concepts of mathematical induction, right? Like we went through the whole idea of the domino system, how it is related to mathematical induction itself. Because the whole purpose of proving an equation is to show that for all of its respective values of n, okay, every single value of n will be true when you substitute the value of n into the equation. Make sense?
Yeah, makes sense. Wait,
Yeah.
can you because like can you email me the formula sheet that you have?
For which one?
This one.
MI
Yeah, the proof. Yeah,
For
mathematical.
MI. Okay. Yeah.
Because I think I need to and how about the way I phrase the sentence? Do I have to like
You mean the steps to solving the
yeah.
MI?
Do I have to follow the phrasing assume that something?
Okay, don't worry. When I send you the cheat sheet, you just follow the cheat sheet.
Oh, okay.
Can?
Yeah,
Yeah.
can.
So after you have the cheat sheet, you just go through it a few times. I mean, you just do the questions using the cheat sheet a few times. It will get into you.
Okay.
Yeah.
Okay.
Okay. So
Yeah.
what we wanted to prove, okay, the whole idea of mathematical induction is that for all values of n, like in this case, the values of n here will be n greater or equals to 1. So 1, 2, 3, 4, 5, all the way to infinity, right? For
Yeah.
all these values of n, this equation will be proven true, right?
Yeah.
So relating it to the domino concept is that we need to show that every single domino piece will topple right from the very first piece. Correct?
Yeah.
Yeah. So when the first piece topple, we now want to show that the second piece topple, the third piece topple, the fourth piece topple, right? But the thing is, in math equation form, I mean, in a form of dominoes, it is easy to see. I mean, like you just push the first one, then after that you just follow the trail, right?
Yeah.
Yeah. But in math, right, it will be super tedious to show that the equation is true for every single value of n. There's no ending to it.
Oh.
Right? Like when n is greater or equals to 1, it's like what? N can take up to 1 million or even 1 billion. Yeah. So how are we going to show that? So that's why we have to use a general term. That's why after we show that, okay, wait, the first domino piece topples, okay, over here, we show that the first domino piece can topple, which is n equals to 1 can topple. Then after that, we are going to assume that somewhere in the center, very good, correct, you still remember. So we're going to show that n equals to k, somewhere in the center, we're going to assume, right? We're going to assume that it will topple, okay, after we push the first piece. Then once the assumption is made, after that, using that assumption, we are going to prove that the next piece, which is the k plus 1 term, okay, if you prove that the k plus 1 term really topples, in the case of mathematical equation, is that the equation is proven true for k plus 1 term, then every consecutive piece in the in this domino system will topple.
Yeah.
Right? Remember? Okay, so coming back to the presentation, so step 1, we always test for, we always define first, let the proposition be whatever. Okay, just copy and paste the question.
Okay.
Okay, then after that, step 1 will be to prove that the left hand side and right hand side are equals to each other for n equals to 1 or whatever the first value is.
Okay.
Okay, then step 2, like you said earlier, okay, I'm glad that you still remember that we need to have an assumption. The assumption is for the k term. Okay, there's no need to prove for the k term because we are assuming that it is true.
Yeah.
Okay, then after that, the third step is to prove that the k plus 1 term will be true. Means for k plus 1 term, we have to prove that left hand side equals to right hand side.
Yeah.
Okay.
Yeah.
Yeah. Then finally, we can just do the conclusion. Okay. So previously, what we learned was the algebraic mathematical induction. Okay, which is for this one. Then after that, we move on to divisibility. Okay, divisibility. there are more setups. So today we are going to go through the rest of the setups. Then we can close MI for good.
Okay.
Then we can move on to something that is troubling you, which is complex numbers.
Yeah, but isn't MI also a very big chapter?
It is. But we just need to go through all the setups today. That's why I want to use today's lesson to finish MI.
Okay.
Can I mean, like, after we go through, if the next you still not very
I
confident.
still have two assignments of
MI.
MI that I haven't done yet. Yeah.
Oh, okay. So maybe what we can do is today let's go through all the different setups first. Then after that we can go through your school practices. How about that?
Okay.
Is that better for you?
Yeah, that's better.
Yeah. Okay. Can. Okay, hold on.
Friday 1 to 3, right?
Friday is you told me 12:20 to 2:20 but you want 1 to 3.
Oh yeah.
So you can confirm with me
Yeah, can because 12:20 is math and I wouldn't want to attend math now because like my school.
Okay, sure, no problem. Okay. Let me. Okay, how about we try for one question to do a recap first. How about that?
Okay.
Yeah, we try one question to do a recap first. Okay.
Well, do you have an e-version of your formula sheet so I can refer to while doing the recap?
I send you after the lesson. I send you
Okay.
after the lesson.
Okay.
Because I want to touch up a bit more first.
Okay.
Okay. Anyway, over here we will do it together first.
Okay.
Can. So what is the first step?
The first step is to prove by induction that that one is to wait. You have to write out the sentence. I assume.
Yes. Define Pn. Right? Okay. So we have to let Pn be equals to let Pn be what?
Pn be 1. Wait, no, that's n equals to. Wait, let p. Wait. Huh?
Let Pn be what? Let Pn be the proposition. Right? Remember?
Yeah. Proposition means what again?
Proposition means like the hypothesis, the statement. Let Pn be the proposition that 1 plus 4 plus 7 plus ... Basically just copy and paste the question.
Oh yeah, that one.
Basically just copy and paste the question. 3n minus 2 is equals to half, which is okay, n times 3n minus 1. Okay, so step 1, we have to define a proposition. Let me use a different color. Let's say orange. Okay.
Yeah.
Yeah. Okay, then step 2, right? What is step 2?
Step 2 will be let n equals to 1.
Yes. Step 2, prove that Pn is true for n equals to 1.
Yeah.
Hold on.
Then
Hold
after
on.
that,
Let me check. Because they said, the question said for all n, right?
yeah. And what? Because afterwards we are still going to k, then k plus 1. And
Okay,
k.
this question it didn't really define properly for the values of n, because the values of n is very important in this case. Because what they wrote here was all n. Can you see?
Yeah, but
All n
all
could have included 0 as well. They didn't mention what is all n. Yeah. So usually in an IB question, they will really state like, okay, n is greater or equals to 0. Something like that.
Oh.
Okay, but in this case, let's take it that it is let's take the first number to be n equals 1. Okay?
Yeah.
Let's take the first number to be n equals 1. Why? Because we can see, I mean, we can tell that if n is equals to 0, the answer will be wrong already. Can you tell? Imagine when n is equals to 0, what will this give you?
-2.
-2, right? If n is 0, what will this give you?
-half n.
Are you sure?
Oh wait, no, it'll be 0.
It was 0. So we know that the first term is not 0. We know that the first term is 1. We have to start from 1. So step 1, we have to prove that Pn is true for n equals 1. Okay, so left hand side will be equals to, sorry, before we even write this, we have to state when n is equals to 1, left hand side is equals to 3 times 1 minus 2, which is equals to 3 minus 2 is 1. Correct?
Yeah.
Okay, then right hand side, 1 over 2 times 1, 3 times 1 minus 1. So what will you get?
1.
1 as well.
Yeah.
So since
Must
left
I put
hand
the therefore sign? The
what?
3 dots.
You mean over here?
Yeah.
You can.
Okay. Okay.
You can. Okay. Let me use a state. Okay. Over here, since left hand side is equals to right hand side, therefore Pn is true for n equals to 1. Full stop. Okay.
Yeah.
So next we have step 3. What is step 3?
Step 3 will be prove that Pn is true for n equals to k.
No, we do
What?
not prove it. We
Assume.
assume. Very nice.
This is the
Correct. We
k plus 1.
assume. Correct. Assume. State that the assumption for n equals to k term is true. Yeah. Okay. So we must state that. So how are we going to state that? Okay. We have to assume that Pn is true for n equals to k.
So we just type in K, yeah. Okay.
Correct.
I try.
So,
Wait, when n equals to K, left hand side. 3K minus 2.
so this is the phrasing. Assume Pn is true for n equals to k. Then this is when you will have your IE, I dot E.
Oh.
Yeah.
Is IB very strict about how you present your answer
Yes.
for MI?
It's not just IB. It's just it's across all exams you have to do that.
Oh,
Across
okay.
all exams you do that. So IE, so you have to write 1 plus 4 plus 7 plus dot 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 plus 3k minus 2 is equals to 1 over 2k 3k minus 1.
Okay. Wait. Oh, wait. Oh, must put the I. Oh, okay. Cause I just now I straight away wrote the top one. I wrote RHS straight away. Yeah. Okay. Kenny, I'm
Okay, done. Okay. Step 4. What is step 4?
Oh wait, so we don't have. Oh, we just assume. Oh, we don't have to show.
Yeah, you don't have to prove. You're not supposed to prove. You're supposed to assume that it is true.
Oh, okay. Okay, so then step 4 will be prove that pk plus 1. No wait, pk plus 1 or pn also. Pn is true
Yes.
for n equals to k
Yes,
plus 1.
okay, you can say that. You can say this. You can say this. You're right. Prove that
Okay.
pk plus 1 is true using the assumption for pk. Yeah, but this is basically, okay, all those in black, right, is basically your guidelines. But all those that are not in black, right, are what you're supposed to present.
Yeah.
You get what I mean? Okay.
Yeah.
So next will be we have to
This is the
state,
assumption for the assumption of pk. Okay.
yeah. So now we want to prove that
We want to prove that.
So over here you can write want to prove that.
Oh, we don't have to put when n equals to k plus 1.
Hold on. We need to write the statement first, right?
Oh, yeah.
Yeah. Want to prove that Pn is true for n equals to k plus 1. Given okay, i.e. then this is what you have to state. You have to state that one plus 4 plus 7 plus dot plus 3 times k plus 1 minus 2 is equals to 1 over 2 k plus 1, 3 k plus 1 minus 1. So this is what you got to show. Okay, look. Okay, so for this question, we want to prove that Pn is true for n equals to k plus 1, right?
Yeah.
Okay, so after substituting in, this is the left-hand side, right? Agree? Hello?
Yeah.
Yeah, and this is the right-hand side.
Yeah.
Agree?
Yeah.
Okay. But the thing is, the right-hand side, right? We can
Yeah.
break it down a bit further. Okay, let's break down the right-hand side. Oh my God.
Equals to half k plus 1, 3k plus 1.
3k,
Plus,
3k plus 2.
wait. Oh, plus 2.
Okay, so
Yeah.
now we are going to work from our left-hand side. Left-hand side will be equals to, okay, so the trick is to always write the k term, to include the k term before the k plus 1 term.
Okay, that's a mistake. Yeah, correct. I think we should be able to get correct answer.
Yeah.
Because I thought it was 3k plus 1. Wait, 3k. Wait, 3. Oh, yeah. Wait. Oh, yeah. Okay. So the 3 plus 2. Yeah, then I think we'll be able to get the correct answer.
You let me know when I can go through it.
Yeah. Yeah, I got it. I can send picture to you if you want.
Can.
Okay. Yeah, okay.
Let's see. You sent me already?
Yeah, send you.
Where? On WhatsApp?
Yeah.
Did not receive, man.
Wait.
Fine, very nice. Actually, really like your handwriting. It's very neat. Yeah. Okay. But still, let me go through. You are right. Okay, but the thing is something can be done to how you present it. Okay, so now let's go through the proper presentation first. So when we want to prove this question, right, the trick here, the trick is to have to show k term. Okay, have to show k term. If you don't show k term, you won't be able to get it.
Okay.
Okay, so moving on. From here, what we can see is that over here, we have this, right? Which gives us this. Okay, because the whole point of step 3 was that in step 4, we want to prove that pk plus 1 is true using the assumption for pk. So over here, we can use the given result in pk already, which will give us half k 3k minus 1 plus 3k plus 1 minus 2. So by opening up this bracket, we are going to get half, or rather 3 over 2k squared minus half k plus 3k minus 1. Sorry, is it minus 1? It's minus 1, right?
It's plus, wait.
Oh, sorry, k plus 1, sorry, plus 1.
Yeah.
Okay, so from here we will have 3 over 2k squared plus
5 over k plus 1.
yes. Okay, if we want to relate to this term, we see that they have a half, right? They took out a half. So if you want to go back to that term, we don't have to really expand this thing. We can show it in factorized form. How? By taking out half from this equation, we are going to get 3k squared plus 5k plus 2. Okay, so from here, by factorizing this, okay, we should be getting half times k plus 1 times 3k plus 2. Which will get us back to here.
Okay.
So we don't necessarily have to expand this thing.
Okay.
Yeah, but you have to show this additional simplification from here to here.
Yeah.
Make
Okay.
sense?
Yeah.
Okay, then the last step, sorry?
So both ways can.
Yeah,
Okay.
but I would prefer not to alter the right hand side by too much.
Okay.
Okay, then step 5 would be to conclude it. Okay, step 5 will be to conclude it. How are we going to conclude it? Okay, let me erase this part first. Yeah, delete, and this one delete. Step 5, conclusion.
Wait, at the bottom of step 4, do we have to write the therefore?
Yes.
Right equals to
Sorry.
left.
Yes, you have to. You have to. Yeah, so you write therefore Pn is true for n equals to k plus 1.
Therefore,
wait. Therefore, Pn is true for n equals to k plus 1.
oh, so I don't have to put the right hand side equals to left hand side.
You can. Then there's no like a strict rule to write or don't write. But you can you can add in that since left hand side is equals to right hand side. Therefore, yeah.
Oh, okay.
Okay, can I carry on with the conclusion?
Yeah.
Okay. So here will be task. If Pn is true for n equals to k. The reason why I say if is because we assume. Okay, we assume in step 3. Thus, if Pn is true for n equals k, Pn is true for n equals to k plus 1. I can confidently say this because we have proved in step 4. Okay?
Yeah.
So Pn is true for so the next step is since Pn is true for n equals to 1. Okay? Because we prove in step 2, right? Then since Pn is true for n equals to 1, with regards to the previous statement, Pn will be true for n equals to 2 and also n greater or equals to 1. Full stop. Therefore, by mathematical induction, Pn is true for n greater or equals to 1. Full stop.
Must mathematical induction be capital?
Don't have to be.
Okay.
Okay.
Yeah.
All right. All right. Okay. You want to take 5 before we proceed?
Okay.
Okay. Take 5. I'll see you back at 4 o'clock. Maybe 4:01 or 4:02.
Okay.
Yo. Are you back?
Yeah, I'm back.
Oh, okay. Okay. It was hell of a question.
Yeah.
Okay, let's move on with another setup.
Okay.
Well, do you know that MOE banned all face-to-face private tuition?
Oh, really?
Yeah. Can like show you. Here you go.
Oh my gosh.
So basically, right, they don't want anybody to have tuition. The only possible way to like have some form of reinforcement in education, right, is by online. Damn shag.
Yeah.
So right, Ethan, if you have any friends who need help in math, right, can get them to join our class.
Oh, online class.
Yup.
Okay.
Like anyone. Oh yeah, remember to help me to subscribe to my YouTube page.
Oh, okay.
Remember?
Yeah.
Thank you. It will mean a lot to me. Okay, let's carry on. So what is step 1? Remember what is step 1?
Yeah.
Okay, this is a brand new question setup. The first setup was the algebraic one. Then after that, previously we did divisibility, right? Now it's inequality. This is the third setup. Okay?
Yeah.
Okay. So step 1, we have to define.
Define Pn.
Yes. See, you got it. Okay. So how are we going to define Pn? So let, same thing again. Pn.
Pn be the proposition that 2 to the power of n more than n for all n more than or equal to 1.
Yes, basically just copy and paste, right? Correct. It's just like that. Okay. What is step 2?
Wait, I'm copying this. Let Pn be. Yeah, step 2 will be prove that Pn is true for n equals to 1.
Prove that.
Pn is true for n equals to 1.
Very good. Okay. Prove that
Kenny, is it possible if we could end latest by 4:20? Because I'm going like to train like at
Oh
around
my god,
4.
can, no problem.
4:48.
Once we finish this question, then we end up. Okay?
This lesson we continue with other questions, right?
Yeah, correct. Next,
Actually, Friday
no,
came
next
longer.
lesson we will carry on with our school questions already.
Oh, you mean this is all?
No, as in I think there's still one more, just one more.
Okay.
Yeah, just because this is the third setup already.
Oh,
Hold on,
how many
let me
steps
check.
are there?
Let me check. Wait. One more. Yeah, just one more setup.
Okay. Our next lesson can extend longer a bit.
Can.
Then okay.
Can.
Okay.
Okay.
Look that 3 is true for n equals to
Okay.
1.
It's true for n equals to 1, right?
Yeah.
Then, how are we going to show this? So you have to state, right, when n equals to 1, okay, when n equals to 1, left-hand side will be equals to 2 to the power of 1,
Yeah.
which is equals to
2 to the power of 1, which is equal to 2, which is which is 2. Yeah.
right?
Yeah.
Okay, which is equals to 2.
Which is more than n, which is more than 1,
Correct.
basically.
That's what you should write.
So
Which is
what? Wait.
which is more than 1 equals to right-hand side.
Can I send you a picture of my working whether it's correct presentation?
Can.
Can, right?
Can. Can. Okay? Then after you have to conclude. Since
left hand side equals to right hand side.
yeah, no, it's not equals. It's not equals. You're not supposed to show that it's equals. Since left hand side is greater than right hand side.
But then your presentation you wrote 2 more than 1 equals to right hand side.
Yeah,
What?
correct. Because it's the one that is equals to right hand side.
Huh? Wait, is my presentation correct then? Because I wrote it differently.
You have to write 1 to be equals to right hand side. This thing.
Yeah, got it. Yeah.
Okay, since left hand side is greater than right hand side, therefore Pn, or rather P1, is true. Okay?
Yeah.
So what's step 3?
How about Pn is true for n equals to
Also
1?
can. Also can. Up to you.
Okay.
Okay?
Step.
So step 3. What is step 3?
State that the assumption of n equals k term is true.
Correct. That pk is true. Also can. You're not supposed to write those in black. You're supposed to write those in orange. Okay? Oops. Sorry. Oops. What? You do. The black color wordings are just your guidelines.
Can I write it down first?
Yeah. Oh, I mean, you can write whatever you want. It's just that during exam, the presentation, you should only write the orange color wordings. Okay, so assume that PK is true for K greater or equals to 1, i.e. i.e. 2K to be greater than K. Okay?
Yeah. Then step 4.
Yeah, step 4. So what is step 4?
Prove that pk plus 1 is true using the assumption for pk.
Yes. Okay. So now we want to prove PK plus 1 to be true, i.e. will be 2K plus 1 to be greater than K plus 1. Right?
Yeah.
Then how? So whenever you want to prove the K plus 1 to be true, you always have to use the PK. Okay? You have to use the Pn where for n equals to K to prove it. So you want to try?
Yeah.
Then you have 2 minutes left.
Uh,
Don't be late for your swim class. Why you still have swim class?
no, we're not doing swim, we're just doing like land.
Can meh? How many people
Yeah.
are there?
Huh? Just meeting my friend only.
Oh, it's not official training.
No, it's not. It's not. You can't have official.
Okay, then how are you all going to swim?
No, we're not swimming. All pools are closed, even condo pools.
Yeah.
We're just doing like non-swimming exercise.
Oh, okay. Should I go through?
Yeah.
Okay, I think I just go through. Okay. So we have to prove using the assumption of PK. Right? Hello?
Yeah.
Yeah. So this question setup, this is the third question setup, right? The first one is algebraic. Second one was divisibility. The third one over here is inequality. Okay. So for this inequality setup, you have to prove it a bit differently. You cannot show from the left hand side to the right hand side. Okay. So we have to like using PK. Okay. We know that 2K is greater than K. This has been proven to be true. Okay. For K, as in this has been assumed to be true for K greater than 1.
Yeah.
Okay. Why I say greater than 1 and not greater or equals to 1? Because we already proved that it is true for 1 already. So K must be greater than 1.
Wait, Kenny, but then shouldn't wait. But then if you both side K plus 1, then it should be the same, because the difference is still the same. They're both added by 1, so they are still the same. Like, as in like there's
I
still
don't
more.
understand. You want to write on the Zoom?
No, cause like if 2K is greater than K, then 2K plus 1.
No, you have to annotate. You have to learn to annotate. I don't know where you're pointing to.
Oh, here. Wait, how do you annotate?
What are you using?
Zoom,
I know, as in which device?
Mac.
Yeah, then you should mouse over the green color meeting ID. You should be able to see annotate.
Oh, yeah, okay. No. Like here. Like this one and this one. Since K plus what? Since 2 to the power of K is greater than K, then 2K to the power of K plus 1 will be greater than K plus 1. Because the difference is still the same. They are both added by 1.
No. How
No.
is that possible? Yo, look, if I have 2 to the power of 3, 2 to the power of 3 is 8, right? I say that it's greater than 5.
Yeah.
Okay, you cannot say that. You cannot, okay, or rather, for instance, 2 to the power of 2 is greater than, say, 3. You cannot say, oh, I plus 1 here means I plus 1 here. It doesn't make sense that way.
Yeah.
It doesn't make sense that way.
Yeah. Oh. Okay. Okay. Then I don't know. Okay. I think you can explain.
Okay, so from here, what I'm going to do is I'm going to convert these two to the power of k. I want to convert to 2k plus 1. Okay, how am I going to do that? I'm going to multiply both sides by 2. Because if I multiply both sides by 2, it should not change the inequality. Okay? So from here, I'm going to have 2 to the power of k plus 1 greater than 2k.
2 to the power of k plus 1 greater than 2k.
Okay, do you agree?
Yeah. Wait, 2. Wait. Yeah, so you multiply by both by 2. Wait, huh? 2. You multiply both sides by 2. Yeah. Okay.
Understand?
Yeah.
The whole purpose of multiplying by 2 is because I want to get the 2k plus 1, 2 to the power k plus 1.
Okay. Yeah.
Okay.
Yeah.
So from here we can 2k is basically what? K plus k, right?
Yeah.
Yeah. And since we know that k is greater than 1, okay?
Yeah.
So k plus k will be greater than k plus 1.
Yeah.
Or rather, yeah, right, agree?
Yeah.
So therefore, 2 to the power of k plus 1 will be greater than k plus 1.
Oh. Oh.
That's all. Okay, you better go off already. Then from here is just the standard conclusion again.
Okay.
Can?
Then
If you
when
don't,
I come home, I'll send to you my finished work.
yes.
Okay.
I will send you the link for this recording also. So if you don't understand the setup or anything, you can just review again.
Okay. Thank you, Kenny.
Okay, bye bye. I'll see you on Friday. We'll do an extended session. Okay.
Yeah, 12:20.
Yeah, we'll do an extended session.
Okay.
Okay, bye bye.
Bye.